Basically, this is some fine time to like do BOF from Pwnable.kr. It's a buffer overflow challenge that can be taken from like naming. So we are told that Nana told me that buffer overflow is one of the most common software vulnerability. Is that true? So we can like download this. Yeah, and we have them. What we can do is like we can give this executable bits. So yeah, so then we can like cut this guy here. Yeah, and we can see that we are declaring a variable overflow me with 32 bits in this like first function. We then print overflow me. We use gets, which is dangerous function to like get the input. The worry with gets is that when you like use man gets, you'll see that it reads a line from standard input into the buffer. No check for buffer overrun is performed. So if you go to the bugs section, you are told like never use gets function because it's impossible to tell without knowing the data how many characters like gets will read. So basically, if you read more than what you can store, you will basically overwrite other things in the memory. So then you are checking key. The key here is the argument passed here in the main function, which is hex deadbeef. It's compared to hex cafe babe, and if it's true, you like land into binsh. Else we like print no, and then we end the system. So we can test the theory where we get no, so we already know that. So using GDB, we can use stack q. This switch is for suppressing the hello message that GDB gives. So we like suppress all that gibberish. The next thing we can do is like set because the default like syntax for GDB is AT&T for assembly, so we can like set that to Intel, then set pagination to off, so that if we like it doesn't print things in pages. Yeah, so then we can like discuss main, and just like we saw, this hex deadbeef is like moved to the ESP, and then the func function is called. So the way we like pass arguments in that 2-bit binaries is through the stack. Yeah, so I have set a breakpoint on the comparison function because we want to like see how this is like going. Then I have a simple layers for like if I want to, I know the buffer for where we are like storing that input is 32 bytes long from the source code. So if I like dump 32 bits long there, I get this is a simple alias. So this does so this is a simple alias. So dump alias dump equals to this. Then so if I like do dump 32, it will like replace that with 32 and then give me this to my clipboard. So if I like run this, then I'm told overflow me. Yeah, exactly. So what you can like do is we can view the stack, like 30 words from the stack from the ESP, and we can see hex deadbeef is here. Basically also you can see like EBP plus hex 8. This means that the value is in another function frame, because EBP plus does EBP minus means that this is a local variable. So you can see our A's are up to here. So basically what this means is that from here we need to calculate from here up to here so that you can know the offset. So 1 2 3 4 5, so 5 times 4, that is 20, plus our 32, that is 52, so the offset is 52. So then we can like change these to hex cafe babe and see how like that works. So if we like set this because this is that, so we can like set this to that, and then if you like view the stack, we like have modified that value to hex cafe babe. So if we continue, you will see a detaching, and then a child process is created. You can see now we land into a shell. The next thing to do, because we know the logic of this binary, is that we can like write a simple script for it. Yeah, so what we first like did here is we imported the Pwn library, and then we imported the sys library. So what this will help us is like manage the argument values, yeah, as we run the script. So we are initializing a new elf value here, and then setting the check sec to false, so it won't be like noisy. Then we are setting a new process, and then from there we know the offset, and then we are receiving the overflow me line, and from there we are setting up our payload and overflowing the value with hexcafable. So what this will do is like it will land us into a shell because of the p.interactive. And as you can see, we have a shell. So what we can like do now is like try to do that now on the remote end, and we need the values for like the remote end, so I'll just copy that from here. Yeah, and so we can try that. Yeah, and since our argument vector is like more than one, we try to do this on the remote end. So this hangs, and I'm curious why it's hanging. So basically it's maybe because of the p.receive. Yeah, and we land into a shell. So okay, so I pawned my own machine, but okay, so we have pawned the remote one and we land into a shell. So if you list, you get a flag value there. So if you cut, you get like this the flag. So we can try to like authenticate it here, and I'm told that you already authenticated this as a flag. So see you next time.